we are going to write the equation of the polynomial that corresponds to the graph. Okay, I think one of the best places for us to start is going to be here and here. These are our x-intercepts. This is the same idea we just had on a situation like this. That was the previous problem where we would be able to identify the roots. Now, what about degree, leading coefficient? Let's not play that game. Here's what I know. I know I have roots at x equals -3 and at x equals +2. Okay, that's all I know so far. There is more to know. We'll dabble with that later. But in the meantime, this is what I know. Okay, good to know. I can reverse engineer a polynomial that will have those roots. And here's what I'm going to do. Let's use blue again. I'm going to just go ahead and say that f of x equals, and I'm going to leave a little gap here and not going to come back to it for a few minutes. But if I had a factor, this is going to be wordy, but if I had a factor that corresponded to an x-intercept of -3, it would be x plus 3. If I had a factor that corresponded to an x-intercept of 2, it would be x minus 2. And this is it. This is totally it. If you graphed this in Desmos, and I'm not going to use Desmos, I'm going to use a graphing calculator, but if you graph this exactly the way it looks, right here, then we wouldn't get that because of the way I just adjusted the window on the previous problem. There we go. It's going to look exactly like that this time. That's going to change in a minute. There's actually more to do that we don't have to do on this one, but we're going to just let this one sit for a minute. If I looked at you and said, hey, what are the x-intercepts of this? You wouldn't even have to think. This is in factored form. Because it is in factored form, I could just say, oh, -3, +2, good to go, done, wipe your hands and go home. You got it. Okay, let's move on to the next one. By the way, if I would have asked for the degree or the leading coefficient, I would need standard form for that. Or at least would need to be able to say, oh, 1 and the 1 makes 2 for my degree. My leading coefficient is a 1. You can do that also. Okay? Here we go. This one has roots at x equals -3 and at +2. Okay, cool. That works. Let's keep going. Looking familiar? Certainly hope so. Obviously, it's going to be great because the sun is shining in, illuminating the notes as I teach. Suddenly, we understand. The light literally came on. X plus 3, x minus 2. That's what we're dealing with. And so we would say, oh, I'm done. This is great. Let's type that in the calculator. You type it into Desmos, you get this. That was the answer to the last problem. These are clearly not the same. What's the problem? What's the problem? You're distracted by this light. So give me just a second as I move my little get up here. Hold on just a second. Saw my reflection in the calculator. All right, sorry, had to get situated there. Back on track. Notice these are the same answer, but the graphs are very different. What do I do? How am I going to manage this? What's the deal? Here's the deal. Maybe, just maybe, I have a leading coefficient that we haven't even talked about yet. Maybe, just maybe, the leading coefficient isn't always 1. Maybe it's 4. Maybe it's a half. Maybe it's -1/2. Maybe it's -1/3. Maybe it's pi. Like, who knows what it is? So I'm going to do something on this problem that I didn't have to do on this one, and I'm going to come back to talk about that on this one. So I'm going to make up a number. We'll call it A. A is going to be that leading coefficient that we don't know, that has the potential to change the shape of this. So for example, if I, and you could do this on Desmos much easier, if I put a number in the front, I'm going to put a 6. If I put a 6 in the front and I press graph, actually let's not. Let's do 6 and then x plus 3, x minus 2. So here's what we're looking at. This is the graph of the very first problem, and this is the second graph, and I'm hoping that I can get the second graph. There's the first problem we did. There's the second problem we did. Oh dear. I want this graph, and I got not that. I got something that looked like this one, just stretched out a whole lot more. So, okay, maybe it's negative. Let's put a negative in. Again, you can tinker with this on Desmos. There we go. Oh, never mind. Flipped it over, but it's still stretched. Okay, well, maybe 6 is too much. Maybe we should go with 2. And again, tinker with this on Desmos if you like, but I'm about to show you a very efficient way of doing it. No. Again, here's what we're aiming for. I want this graph to look like that one. So we can keep changing the number and guessing, but let's just jump to how it can be done. Here's what I recognize that I hope you recognize as well. We have a y-intercept right here, and that y-intercept is super important. It is at 0, 3. I will use that coordinate to figure out what number goes in the front, which eventually is my leading coefficient. Now again, the number in the front here isn't always your leading coefficient. If you don't have other understood ones here, it throws it off. For now it is, so we'll keep going with that. So I'm going to use 0, 3. I'm going to use whatever point I can and figure out what A is. So this is going to be super duper easy as long as we can wrap our minds around it. X is 0 and Y is 3. So 3 equals, I don't know what A is, 0 plus 3, 0 minus 2. Multiply those together, that's 3 and negative 2. That's going to give me negative 6 and A on this side and 3 on this side. So we'll divide by negative 6. What are we doing? We're looking for the number that goes in the front because I just kept experimenting with it and I never could quite get it right. Again, faster on Desmos, but this method is so clever. Wish I'd have come up with it. 3 divided by 6 is half. It's negative 1/2. So I know what A is now. A is that number in the front. In just a second, I'm going to write my final answer, but let me demonstrate this to you. So in the front here, I'm going to have negative 0.5. So this is the very first problem. This is the second problem. And when I graph it, first problem we did. Second problem we did has a correct y-intercept. Lucky us. All right, good. Final answer, I'm going to write it. I'm going to write it in red just because it's fun. They said write the equation of the polynomial, and on your assignment it'll say in any form. You can multiply all this out if you like. I'm not. So negative 1/2 and then x plus 3 and then x minus 2. This is my final answer. And actually that was my final answer here as well because having an understood 1 in the front, check it out. Having an understood 1 in the front would give me 0 and negative 6. Here goes. Write this or not. It's up to you. This is the answer because there would be an A there. Negative 6 equals A. 0 plus 3, 0 minus 2. That gives me negative 6. Negative 6A equals negative 6. So A equals 1. So why even write it, right? So final answer on this one. We already knew it, but we just demonstrated that that was truly a 1 and we should never make that assumption. So 1, x plus 3, x minus 2. Okay, let's speed this process up. Here's what we're going to do. We're going to write the next couple in factored form. Factored form is a perfectly acceptable way of doing it. Factored form is an easy way to identify roots. If I handed you this, you'd say, oh, x-intercept at negative 3 and at 2, right? Okay, here goes. I hope you notice this point, and this point. Those 3 points, my friends, are the roots. We have roots at x equals negative 3, negative 1, and at positive 2. Therefore, we will write our function, and it will look like this. We have no idea what's going to go in the front. We'll figure it out in a minute, though. X plus 3 is opposite of that. X plus 1, x minus 2. Okay, fantastic. How are we going to figure out that point? Well, this is where we pull out the pen again. Notice that dot right there, and that dot right there is at 0, negative 6. I think in this case, we're going to just go ahead and end up with a 1 there. Man, I'll ruin the whole thing. Negative 6 equals A times. Okay, shortcut time for this case. If you're going to plug in a 0, then basically you can just forget all your x's and you're going to have 3 times 1 times negative 2. And you could do a lot of that in your head. You could even skip this step if you like. 3 times 1 times negative 2 is negative 6. A equals negative 6, so A equals 1. My final answer is f of x equals 1. x plus 3. Yes, it's what I wrote the first time, but we didn't know for sure that that was a 1, and now we do. All right, moving along, going even faster. Slow the video down if you need to. You have that luxury now. So we're going to notice that point, and that point, and that's going to be a little tricky. We have roots at x equals -8, -3, and at 0. Okay, so let's just start writing. We have a polynomial function. Always start it with an a. I'm going to start also with this. If I had a root at 0, then we would say x plus 0 or x minus 0 is a factor. Let's back up here for just a second. Notice we had 4x and ended up with a root of 0. That's why the x is here, because of that 0. Okay, moving right along. X plus 8 and x plus 3. I know I wrote those in the opposite order. I said them. It doesn't matter what order you write it. I do want the x in the front after your leading coefficient. Okay, I would love to identify a y-intercept, but it's 0. So plugging in 0, 0 would help me none at all. But they did give us this coordinate, 1, 3, which we can very easily use. Lucky us. So 3 equals a times 1, 1 plus 3, 1 plus 8. Okay, 3 equals, all right, 4 times 9, that would be 36, times 1, a. So we have 36a, we're going to divide by 36, and a equals 3 over 36. That reduces 1/12. I know what a is, you know what a is. The final answer is, let's go back to the directions, the polynomial that corresponds to the graph, okay? That would be all the stuff, but now we know what a is. So final answer, f of x equals 1/12 x, x plus 3, x plus 8. If you reverse the order of these, it is not a big deal. Okay, we have 2 more with graphs, and they're going to get a little bit tricky. So on the back side of the paper, mine's a separate piece. Let's proceed. We are going to have roots at x equals, okay, well, there's 1, -3. There's 1, -1. Not there. We'll deal with that later. And there's 1. It is +5. But there are some special things to notice about this. All right, here we go. Back to the very beginning. That double root, where it was squared, it made it look like a parabola. This double root, instead of passing through, I hope you can remember what the graph looked like. If you can't, don't panic. I'm about to graph it again. The double root on the very first problem was basically in that general area, what looked like parabolic. So at 4, it bounced off the x-axis. Looks like a parabola to me, my friends. This is a double root. Now, we're gonna talk about that in a minute, because that is not a safe assumption, but for our purposes it will be. This is a double root. There is another word for that you're going to meet in just a few minutes, and it's that, a multiplicity of 2. That means that the root technically happens twice. Okay? Notice this guy right here. He looked cubic. I hope you remember this problem that had the 5 that looked cubic in that general area. This is a triple root. This one is not. It just passed right through. It's not a straight line, but you can think of it as almost like a linear root. Clearly not a straight line, and not a parabola, and not cubic, but it has that general shape in that area, generally. Okay, here we go. F of x equals, here comes the Zamboni again, so the ice skaters can get back out on the rink. X plus 3. I have to talk above the sound of that thing. I don't know how well this microphone's picking it up, but it is about the loudest thing I've ever heard in my life. Okay, I've left some stuff out. Let's fix it. X plus 3 was a double root. This was a linear root, passed right through. X minus 5 was a triple root. Okay, and here's the thing I'm not telling you that I'm going to tell you. When you leave things out, conspiracy theories are born. So here's the thing I need to go ahead and tell you. I am assuming it's a double root and not a root to the 4th power or 6th power or 8th power or something like that. Because any of, and this is worth graphing, not like that. No, there we go. If I have x squared, if I have x to the 4th, if I have x to the 6th, I'm going to get the same general shape on all of them, and they're all going to look kind of like a parabola, but some of them are skinnier than others. See? See what I mean? So the question is, how do you know it's squared and not to some other even power? I don't. So for simplicity and for our purposes, he always stalls right in front of my door. I appreciate the work he's doing, but he stalls right there. It's the Zamboni. For our purposes, we're going to say, you know what? We're going to just treat it like it's a parabola, and we're not going to play this game of trying to guess if it's a 4 or a 6. Similarly, if this was a 3 or a 5 or a 7, we would have some very similar shapes, but some would be thinner than others and very difficult to tell apart. Very difficult. See what I mean? So for simplicity, we're going to go with the lowest possible thing it could be, which would be a triple root. I just don't feel like messing with other things. All right, back to the problem. In higher mathematics, you can mess with that. It's fun. All right, 0, -3 is a point. It's a thing. So 0 plus 3 squared. Yes, that's 9. 0 plus 1. Yes, that's pointless. 0 minus 5. And yes, that's cubed. We have a lot to do here on this one. Lucky us. -3 equals, 9 times 1, well, that's 9. -125, in case you care what -5 cubed is. And so 9 times -125 is -1125. Ooh. Let's divide by -1125. And we get a positive number. And it does reduce, and I already have the answer here. 1 over 375. Wow, that was odd. Well, technically it's a fraction, so it's not odd or even. But the final answer for this one is going to be f of x equals 1 over 375, x plus 3 cubed, x plus 1, and x minus 5 cubed, and that one should be squared. Oh no, I made a mistake. And as my punishment, the Zamboni goes by. All right, last problem. We're going to go very quickly on this one. I'm going to try to talk above the sound of them smoothing out the ice on the ice skating rink. Roots at x equals -3, 0, and +3. I would also like to point out the general shape of this. Always notice the shape. Bounce here, we will assume that's a double root. Not a bounce, and it's not a cubic. I used to say it lays on the axis. That's, first of all, it's bad grammar. And second of all, it doesn't lay on the axis. But that's kind of a good idea of just sort of thinking of it kind of like that. But that doesn't happen here. So bounce off, pass through, bounce off. So anytime you bounce off, for our purposes, this is going to be a double root, and that's going to happen on the -3 and the +3, not the 0. So we have the function, which is a, because we don't know what comes in front. We do know x because of the 0, so like x plus 0, but why would we write that? And then x plus 3 squared and x minus 3 squared, and lucky us, we have a point, 1, 128. Let's plug it in. You don't always have the y-intercept. Actually, we do have a y-intercept, but again, plugging in 0, 0 would really not help at all. So plug in a 1, you get 1. Plug in a 1 here, you're going to have 4 squared. Plug in a 1 here, you're going to have -2 squared. And so 128 equals, let's see, that's 16 times 4, that's 64. Hey. A is 2. Told you I'd go fast. F of x equals 2. Where'd you get your 2? It's that. It's A and then all the other stuff. So 2x, x plus 3 squared, x minus 3 squared. There it is. Let's put it in a little red box.